All right. Good morning, everybody.
Good morning.
I think a lot of people were up late last night.
Is 3 a.m. late?
It depends who you are, I suppose. For me, that used to not be late. Right now, I would be like dead. I've become a morning person.
I needed to make that transition.
Yeah. Well, so I haven't had a chance to look at any PA2 submissions yet, obviously. Um, but I can tell you about a third of the class has apparently not pushed anything over ever for PA2, which is alarming for a couple of reasons. One, because you really should be pushing code over as you work on the project, and it's three commands, and you can make a script that will do git add, git commit, git push, and you can make an alias for that and just say go, and it'll push it over to git, and it's there. And if you forget to upload, Friday morning, Thursday night, if your internet goes down, if you have to leave town in a hurry or something, right, the last version that you had is still there. And so there's really no downside to pushing stuff over as you work. But a third of the class has not done that. The second issue is that, obviously, if you run into a problem at 4 in the morning on Friday with Git, it can be hard to get help, right? Git is such a huge kind of behemoth that if you go to Stack Overflow or any other sites like that, you're going to find so much information. You're going to start checking out branches and stashing things, and it just becomes this big, and you're panicked, and you don't want to lose your code, and so on. And you can avoid all of that by pushing as you go. And if you start your assignment, if you started it last weekend and you tried to push and you got some talkback from Git saying, can't push, fast forward, blah blah blah, right? You can hop into office hours. You got a whole week to figure it out. So that's the second, really good reason for using Git as you work through your project is it avoids those last minute surprises. And if your repo is not downloadable by me, I can't grade your project. And I'm probably not going to get to grading until Sunday afternoon. And so at that point, if I can't get to your repository, right, you probably don't have enough slip days to be able to turn it in late. And it's going to end up being a 0, and that's a shame if you've spent all this time working on the project and you've got it working or close to working, right? And so yeah, commit along the way. Git add, git commit, git push, origin master, and it's there's no downside, right? Make a command and it's just go, and it's done. So I had a few people come in office hours. I had a few people email me and tell me they were going to take slip days, which is cool. Had a few people come in office hours and work through some details, but I don't know what to make of the other 15 or 20 missing repos. So hopefully you're on top of it and you can figure it out and get something pushed over by 8 o'clock tomorrow. All right, so go ahead and send me an attendance note. Let's see who's here. And it looks like our attendance is dropping off.
Maybe because it's Friday.
Maybe because it's Friday, yeah. Clark is funny. Like for a while, the campus was actually like closed for part of Friday. It's just considered like a non-day or something. And my classes always go like Monday through Friday, so I don't know.
I really can't wait for next term.
Be back in person?
Learn calculus and physics online.
Yeah. I'm looking forward to being back in person. There's advantages to being remote, but there's definitely advantages to being like face to face, and that'll be good.
I remember when the building was like closed at 1 on Fridays.
Mm-hmm. Yeah. Yeah, I used to run a lab Friday nights, and security would come in about 8 o'clock, and they'd kind of give me a stink eye and say, you know, the building's closed. So
how are you able to run a lab if like?
They would usually work with us. They'd look at my badge, and eventually they got to know me, and they just knew I was doing this Friday nights. But if there was like somebody new working that shift, they'd see all these people in a room in a building that they thought was closed, and you'd have to explain it to lab time and all this stuff. So that was in the old building. That was in APH. And in the STEM building, it doesn't usually happen. But security is so cool on campus. They're like, it's the first time I ever like worked with a security division of a company or a college, and they're like super cool. They do good stuff. Let's see, what exactly do you mean by missing repos? If we have the stick.c and stick executable in the GitLab folder that we have shared with you, that's all you need, correct? Yeah, long as it's you know, on the Git repo that you already shared for PA1 and for the homework, you should be fine. Yeah, sorry for the scare.
I have a question about the GitLab.
Okay, yeah.
So in my PA2, like my stick program, I called a different function.
Okay.
I think to like determine how many sticks the computer takes. I put that function also in my PA2 and sent it. Is that fine?
What does that mean? What do you mean?
So like I called a function in my stick program, but I also sent you that function that I called.
Oh yeah, definitely. Yeah, I need that. I need everything. Everything that I need to be able to compile your program has to be in that repo.
Okay, perfect. I was just making sure that was a thing that we could do.
Oh yeah, definitely, absolutely. And by the time we get to the end of the course, our projects will probably have, you know, several files and a make file for putting them together, and maybe a README and maybe some text files, and all of that can just go in the repository. If you just do git add star, they all get pushed in, and they end up over there. Kind of automatically.
Is ODP 12 today?
ODP 412 was due, I think, at 8 o'clock, at 10 o'clock this morning. Or maybe that was the day before, I don't even remember.
Which one?
I think 412 was today? Or maybe that was the day before. Day before, okay, yeah. So we didn't have an ODP yesterday. Yeah, cool. 412 was due on the 14th. All right. Let's see. So let's talk one more time about scanf and argv and argc, and this has been causing people a lot of issues. And so let's try looking at this with some code. So let's do the standard main program with a pair of arguments.
And typo and include.
Sorry? Yeah, include. Thanks. All right. So let's not repeat stick. Let's say that we just want to get a number from the user, and it should be a number from 1 to 5, right? Or from 0 to 5. So let's try something like this. So just an integer number, we'll scan argv bracket 1 with a %d, we'll save the result in number, and let's throw an if statement in here. If number is less than 0, or number is bigger than 5, we'll print a message. All right, so just junk code, right? Playing around with these functions. All right, so I say main 4 and it says your number is 4. Hey, that's great. I say main 6, it says your number is out of range, your number is 6. Great. All right, so the problem is twofold. Number one, if I say main haha, it says your number is 32765. And it told me it was out of range, but you know, here it was 32766. And what I'm going to get for my number is more or less random. And you know, it's possible that my number could end up being 2, which you would think was in range, right? And so this is the first issue, is doing this does not tell me whether or not my number was converted successfully. And I can't say, you know, if number equals 32766, then print error, because it's not always equal to 32766, right? It could be different things. And I could say if your number is really big, you know, but maybe I want a really big number. So how do we know if sscanf found an integer in this argv bracket 1 or if there was a problem? And the only way to do that, the only reasonable way to do that, is to check the return value from sscanf. And if you look at the manual pages for all of these scan functions, the return value it says these functions return the number of input items successfully matched and assigned. So I'm asking it to match one pattern, an integer, and assign that to this variable num. And if it does that, it will return a 1.
I have a question.
Sure.
Out of curiosity, if you were assigning like a parse result to scanf there, to see if you actually successfully scanned something, what if you went over the overflow limit of an integer? Would it be a 0?
When you overflow an integer, I believe that it will just it will literally just roll over, so it depends on how much you roll over.
Oh yeah, that's right.
So you will have, like, I was testing this because I was trying to see if is there a way for me to make it so you can only enter so many numbers, and I realized, I don't know if I couldn't, so I just said, you know what, the user decides to put in 2 billion, or like 3 billion, whatever it is. Actually, I think it's like, I think it's that.
Yeah, it's like 2 billion.
And rolls it over, and it works still. That I just say, you know what, fine.
Yep.
You decide to put a big number, you will suffer the consequences.
Exactly. Yeah, and that's a good attitude to take with these. So one thing you'll see me or hear me say sometimes is if scanf likes it, then we like it, right? So for example, if you put spaces in the beginning of an integer, %d will still match it. That's okay. And if you put in a big number that's out of range, right, it will convert as an integer, and it will tell you it's an integer, but it won't be the integer you typed in. It will roll over or truncate or do something. That's okay too. We're not going to, you know, try to make something that perfectly works in all possible situations, but we do want to, you know, catch things like this and say, hey, that's not even a number. And so the way to do that is to look at the value that sscanf returns. So this return value, that says if you say, you know, variable equals sscanf, the return value is what gets stored in that variable, right? So it's the number of input items that were matched, right? It will be 0 if no input items are matched, but it'll actually be a special value called EOF, which is -1, if there's nothing to convert, if the string you pass it is empty. So there's lots of things that can go wrong, but the thing that goes right is when sscanf returns 1. So integer number of things converted equals, and this is a dangerously long thing to type on a Friday, number of things converted equals sscanf. So now I'm going to say if number of things converted is not equal to 1, that's a syntax error. And I'm just going to do a return here because I don't want to go on and see if my number is less than 0 or bigger than 5. If it's not a number, the reason that sscanf returns a 0 is because it stored how many variables? 0. It did not change the value of num. And so doing this is pretty much meaningless. Now if num is the integer version of what you typed, then yeah, let's go ahead and see if it's between 0 and 5. But if this does not return a 1, it means num is still basically undeclared. And so checking to see if this undeclared random number is between 0 and 5 really makes no sense. Does that seem reasonable, everybody?
Yeah.
So now if I do main, it does that. If I do main with a number in range, it does that. If I do main something else, it says that's not even a number. But this still has the issue that if I say main 2.3, it'll say, oh yeah, your number is 2. Because sscanf does not have to match the entire string. When I say let's scan and let's look for an integer, as long as it finds an integer, it's happy. It'll store that, it'll return a 1, saying, hey, I converted one thing. And if there's extra stuff after that, it doesn't care. Right? Now, if we care about that, what we'd like to do is detect that there's extra stuff after that. And so this is where we do this trick where we say, okay, let's just not scan an integer, but let's also try to pick up some extra characters after that. We don't want to find extra characters after that. We're hoping that it stores an integer right here and that it fails to store anything else. Right? If the user types in what they're supposed to type, which is just an integer, then we should get an integer stored in num. That's one thing that's been converted. And it should fail to convert anything else and store it in this extra. So number of things converted should be equal to 1.
By the way, out of practice, how long should we make extra, like for our programs?
So for when we've been doing this in class, I've just been doing 120. You would have to type, 120 characters for this to get you into trouble. It can get you into trouble. If you typed 1,000 characters, we'd probably get a seg fault. But I'm not going to test your code like that. This is another one of these kind of slightly sloppy things that we're doing.
What would you do in the real world if you wanted to check inputs?
In the real world, if you wanted to do this, you could check the length of argv, bracket 1, or whatever string it is. If it's smaller than 120, this is a totally safe statement. If it's bigger than 120, I would just throw a null terminator somewhere in here, and that would terminate the string at 100 some characters, and then this would be a totally safe thing to do. But if this string happens to be 1,000 characters, and I say %s and there's no spaces in there, it'll just go ahead and load it into memory starting at this location, and it'll just overflow, and then you've got a potential issue.
You gotta do a lot of checking in this language.
Yeah, it's really not it's not designed to do anything other than give you a way to write assembly language that's a little more convenient than assembly language. Now something like Java is another extreme of this spectrum where, it's almost impossible to just get an exception in Java. If you type a statement that could throw an exception like a seg fault, right, you've got to write code that will manage that. The compiler will force you into that. It's really kind of designed to not let you have buffer overflows and seg faults and things like that. C is pretty much, you know, kind of Wild West. All right, so if we compile this and we type in something like, you know, 2.3, it'll tell us, no, that's not even a number. And we could make this, you know, a little more nuanced. We could say if number things converted is less than 1, then we could say that's not even a number. We could say if number things converted is equal to 2, but we could give a little more detailed error message. If the number of things converted was equal to 2, then we could say, hey, that started to look like a number, but it had extra stuff after it. So main, you know, with that's not even a number. Main with 2.3 started like a number, but it had extra stuff after it. All right, so the problem we get into with this is if you just say main, and you get a seg fault. All right, so this is where a lot of people were stuck yesterday. Is this stuff was working when you put an argument on there, but if there was no argument, you were getting a seg fault, right? The reason you're getting a seg fault is this statement right here. All right, so why is this giving a seg fault? When you run a program like main and you put an argument on there, these arguments go into an array called argv. And in this case, if I say main space 23, argv bracket 0 will contain a string main, argv bracket 1 will contain a string 23. And the reason that we're doing an sscanf on argv bracket 1 right here is because what we want to do is take this argument that they put in after the word main and convert that to an integer. Right? That's the whole deal here. The problem, though, is if they just say main, well, the word main goes into argv bracket 0, but argv bracket 1 basically does not exist. There's no argument to put into argv bracket 1. So that thing is not a thing. And when you try to do an sscanf on something that's not a thing, you get a seg fault. It's kind of what seg fault means. Hey, there's nothing there. And so the code is doing exactly what it should, right? You're trying to convert this non-existent thing to an integer. Well, that's kind of a silly thing to do, right? You can't convert an imaginary non-existent thing to an integer, and you're asking sscanf to do this, and it's like, I don't know how to do that. I don't have an imagination. So it throws a seg fault. So the trick is, right, before you execute this statement, let's make sure that you're not dealing with a case like this. Right? Let's make sure that you don't have a situation where you don't have an argument here. All right, so how do we do that? We look at argc. Argc says how many things do you have on the command line. In this case, argc will be 2. In this case, argc will be 1. Argc is also telling us how many things we have in our array of arguments. 1, 2 things here, just 1 thing here. So if argc is 1, we know that if we try to scan this, the thing's going to throw up on us. So we can stop that seg fault from happening by putting a check before this. Hello. right? So we'll just say if argc is 1, we'll say, hey, you didn't give me an argument, and we'll just get out of here. So now if I just say main, no harm done. And if I do this, it'll go on and so on and so forth. Now if I don't do this return, what's going to happen? If I just say main, it'll say, hey, you didn't specify an argument after main, and then it seg faults. Why is it seg fault? Because I printed my message, and what did I do next? I went ahead and I tried to use scanf on this thing that doesn't exist. And that threw a seg fault. And if you do something like this, it's still going to seg fault. Even though I check to see if argc is equal to 1, I'm checking down here. And when my program starts, remember it begins right after the curly bracket in main. Well, those are just declarations. That's just empty space. What's the first instruction it's going to do? It's going to try to scan, and it's scanning this thing that doesn't exist. And that throws a seg fault. It never even gets down to this code, because once you get a seg fault, your program exits. So the order is super critical. Everything happens sequentially unless you make it do something other than that, like having a loop. And so for the stick program, right, if argc is 1, we don't just give up. We ask the user how many sticks. We get a line from them. We scanf that line, and then we check to see if it's at least 20 and so on. But that's an idea of how we can, you know, pick up arguments and deal with these special cases. And even with all of this, right, we're still not picking up the case where we have more than one thing on the command line. And maybe we care about that, maybe we don't. For the stick program, we do. We want to have, if there's anything on the command line, we just want one thing. We want it to be an integer. So our program, our main program, is not noticing that we typed in 2 things on the command line. So we actually need something more here, right? So we could say, if number of things converted equals 2. So argc, if argc is 1, we can say, hey, you didn't specify an argument. We could say if argc is bigger than 2, print out, hey, you had too many arguments. So there's no arguments, there's a single argument, there's too many arguments. This is a lot, right? 708 characters, well, some of that is print statements, but 33 lines, right, of code just to deal with, you know, reading input from the user. And we're not even dealing with the case where we let them type a number in on the input while the program's running, right? We just kind of kick them out if they didn't put an argument on the command line. So I mean, just the preamble for your stick program where you're deciding how many sticks to play with, you know, it could be 50 or 60 lines of C code. Right? There's a lot of processing to go in there. Let's see. And yes, so someone just suggested, and yes, we could put all of this code into a separate function if you wanted, right? So our earlier ODP where we passed argc and argv to a function was a way that we could bundle all of this. So let's do that. So let's So there's my simplified main program, 2 lines. I'm going to call a function we haven't written yet called process that takes an argc and argv pair of arguments and returns an integer. And my goal is this integer is going to be either the number that you typed in between 0 and 5, or it's going to be -1 if there was any kind of error. So let's write this function, integer process. And the rest of this I'm just going to kind of leave the same. So if arg is 1, I'm going to say, hey, you didn't specify an argument, and I'll return an error code. If you listed too many arguments, I'll return an error code. If there's a syntax error, I'll return an error code. If there's a syntax error because there's extra stuff, I'll return an error code. If the number is out of range, I'll return an error code. Otherwise, I'll just return num. Is there a way to have the function print a string like hello world and return that to me? We could return a string. It's a little bit tricky to do. But we could declare the function itself to return a car star. You just have to be a little careful about what string you return, and that gets into like dynamic versus static storage. So it's doable, but it's a little odd sometimes. But we'll talk about it when we get more into memory issues. All right, so here's the prototype of my process function. Here's my whole main program. It's just 2 lines. And so let's compile that and see how we did. Hey. So there's main, it gave me an error, -1. Here's main 2.3. Here's main 66. Here's main with extra arguments. Here's main with something that's not an integer. All of those things, I'm getting back my flag saying, hey, there was an error. And if I put a number between 0 and 5, I get back that number. So now if I did this for my stick program, right, this could be process argc, argv, get the result. And if result was -1, I just return. Otherwise, I know that result is the number of sticks I want to play with, and I go ahead and I run my code to play the game with that many sticks, which could also be another function. Right? Again, you don't need to do this, and if you haven't finished PA2 yet, this probably is not the way you want to go, right? This is more complex than just putting it all in the main program. But if you're thinking in terms of modularizing, right, this is something we can do. Because if my main program consists of functions like this, it's going to be a really short main program, and it's also going to be easier to develop and debug. Right, and I can take this and put it into a separate file like this, and now when I want to compile, right, I just list all of my .c's. Oh boy. Gotta include that. Right, so now my main program is really nice. It's 8 lines, you know, and that's just a lot easier to work with sometimes. You get into the editor and your program is right there. You can see your whole program on one screen. These little things make a big difference, you know, especially at 3 a.m. When you've been staring at this for a while. But the other thing is, you know, I have this function process. I can test this. I can change it. I can run it, you know, from a main program like this. And once I feel like this is working perfectly, it's out of my head, right? I'll put some comments in the beginning that say, you know, what this takes, what it does, what it returns. I don't have to think about it anymore. I'm done thinking about argc and argv and segfaults and all that kind of stuff. It's a function, right? It's like printf or scanf or fgets or square root. You just use it. And if your main program is simply using a bunch of functions, right? You're playing with Legos. You're taking things and you're just putting them together and making whatever you want. So this breaking into functions is useful in a lot of ways. All right, let's do another attendance ping, because a couple of other people popped in. This paper for argc, argv. Yeah.
Can I ask a question about what we just covered?
Sure thing.
So I was, when I was writing my program, I wanted to do all that validation now it's like on its own function as well. But if I just had it return, then it's still going to go through and execute the rest of the program, but I wanted it to stop.
Mm-hmm.
I included the standard library and included the exit function.
Okay.
Is there a way to do that, or is that just the best way to do that?
Were you trying to exit from your function that you called?
Yeah.
Okay, yeah. So that's a little tricky. You can use exit. That's totally fine. But another option is to have your function return a value and use that value to tell whether or not you should go on. So for example, in here, I said, result equals process. I could do something like this. Right, if results -1, I got an error, I'm just going to return. Otherwise, I'm going to go ahead and print out what the result is. So if I get an error, it just gives me the error message. But if I put in a good number, then it'll show me the result. That works well unless you have a lot of things that you want to return. You're already returning something else here, and there's no way to put a flag in. And then you can start getting into, returning like a structure or something like that. But for working purposes, yeah, just doing an exit from the function works fine. The only downside to that is that can make the code a little more confusing when you're trying to work with it, because usually when you call a function, you expect the function to come back. But if you're the person writing this and developing it, that's not a problem.
Yeah, that makes sense. In the future, I think I'll try to do it the way you just showed.
Okay. Yeah, so return an error code, use that code with a switch statement. So the other thing is, if I was actually writing this, generally I would not want to put these print messages in here, because those might be great for debugging, but I might want to do something different, or maybe I just want to know if this succeeded or not. Or maybe, I don't want any of these error messages at all. Maybe I want to do something else. I want to look for an initialization file that says how many sticks to play with, right? So what I would probably do is return a different number in each of these cases. If you don't specify an argument, return -1. If you have too many arguments, -2. If it's not a number, -3. If it's got extra stuff, -4. If it's out of range, -5. And if it's a good number, then I'll return num. And then in my main program, I could look at the result and I could do whatever I wanted up here. Right? I could say if result's -1, then halt and catch fire. If result is -2, let's go ahead and ask another question, and so on. And this is all stuff you get to decide, right? It's basically up to you. It's your creation, modulo the fact that you got to follow certain requirements because you're getting graded on it. But how you make it do those things, right? That's pretty much up to you.
Best thing about being a programmer is being able to name the stuff you make.
Yeah, totally. And write the comments you want, and I listen to a lot of music in general. When I was in college, I was always listening to music, and when I'd be at a point where I was in a rhythm and I was writing a lot of code, there'd always be song lyrics popping up in my comments, right? Usually a lot of Pink Floyd, and my teachers would wonder, what does this mean? But
Awesome.
it's a creative process, and it can be a lot of fun. All right, so that's some ideas on the whole command line parsing business. And I've mentioned this before, but on Canvas there's this link to this optional textbook called I Can See Clearly Now, and all the stuff we've been talking about is summarized in like 5 pages here. Actually, it's like 4 pages for input and parsing. So this talks about. It's called Additional Textbook. It's on Canvas, somewhere up in the beginning section, and it talks about why we don't want to use scanf, why it's good for quick and dirty, but if you make a typo in a loop, you can get stuck. And so it talks about separating input from parsing, right? Ingest and parse is what I was calling them in class. And so we ingest using fgets and we parse using sscanf. So this is just it's written down instead of listening to it on video. But this might be useful. And in general, this book is meant to be kind of a bridge from 121 to 224. Depending on where you are, if you've been doing a lot of C programming on your own, or if you did 121, a year ago and have forgotten a lot of it. It's got a few pages on dealing with strings and a little bit about pointers, and then it's got a whole chapter on pointers. I think that's the longest chapter. It's like 10 pages. But it goes over the star and the ampersand and how that relates to arrays, and there's a blurb on argc and argv, and if you want a reference that's a little more focused on what we're doing, then say, just going to Google might be, it's a pretty fast read, and I wouldn't read it cover to cover, but if you're stuck on something, you could take a peek in there and see if it helps. So I just wanted to mention that. I'm getting like blinding sun behind me, which if I set it up just right could look really cool, but probably not.
Kind of looked like you were getting abducted or something.
I know, right? All right, so let's see. So any other questions on that, or on PA2 issues, or argc, argv, inputs, seg faults, all of that?
No, but it's definitely refined the ideals you've been trying to build this week.
Okay, good. And we'll take a week from the big programming assignment. We'll do some more ODPs next week, and then I think PA3 I'm still going to do another C program, and it'll be another game. But we'll talk about that end of next week, and that will probably involve more logic inside the guts of the game, and hopefully the getting the input from the user and interpreting it and error checking. Hopefully that's stuff that will be quicker to do. Bye, see you later. But we'll talk about that next week. I have to put that together still. All right, let's see.
Did we talk about midterm?
Midterm is, I believe, a week from today. Is that right?
Oh boy, what's that on?
What's that on? It's on C and Bash and Unix. So yeah, we'll talk about it more next week. But basically, the midterm's going to be probably a bunch of short programming questions. So I'm not going to say write a stick-picking game, but I might say write some C code to take a string and convert it to an integer, and if there's a syntax error, print an error message or something like that. and some of it will be Bash, some of it will be C. But yeah, it's going to be primarily short programming questions. And the midterm is during class time, right? So Friday at 10 o'clock, and it'll run, for 50 minutes unless you have extended time allowance. And you'll upload a PDF with your answers by the deadline. And the exam itself will just be a PDF you can download from Canvas that'll open up at 10.
You said it's a bugger. Is it gonna be during class? Like, how long
Yeah.
are we given for it?
10 o'clock to 10:50.
Oh, sweet.
Yeah.
Although that means I'll have to do it at work.
Oh, okay. And yeah, you can use your notes. You can use your own code. But that's
Does
it.
that mean we're gonna have to write code
Yeah, it's pretty much all going to be writing code.
by hand?
Oh, you can type it in because you're going to upload a PDF.
Okay.
But you're going to want to figure out how to do that ahead of time so that, like, if you're using Word, it's going to capitalize every time you type I, and it's going to capitalize the first letter of every line. And so figure out how to, use your favorite plain text editor, whether it's Notepad or WordPad or Notepad++ or whatever, and convert that to a PDF. So we'll talk about logistics next week. But that's the basic setup. And yeah, it's open book, open notes. You can use your own code that you've already done. You can use your ODPs that you've already done. But you're not allowed to use the compiler. You're not allowed to use syntax checking editors. You're not allowed to use online resources like Google or Chegg or Code Hero or anything like that. Yeah?
Will we be docked points for syntax errors, like really small crap?
If you miss a semicolon or you type a stray curly bracket or something like that, that's not a problem. But if you write your main program and you say integer argc comma integer argv instead of char star star, right? That's something you should have typed enough by now that you would know it. So I would take off a point or two for that. Usually the things people run into are writing code that just does not make sense, that algorithmically doesn't do what they're asked to do, or that would blatantly throw a seg fault or things like that. So it's weird to write code by hand and not be able to test it through a compiler. I admit that's an imperfect way to assess, but I have not found a practical way to do anything other than that yet. Other than do oral exams, and I may go that route later on in the course or in the year. But for now, we're gonna try this. All right, so what I want to do next, and this is going to wait till next week, but I want to talk a little more about char star star and dig deeper into how that works. And I'd like to start playing around a little with GDB, the debugger, because that's going to help with the next programming assignment. I also want to talk a little about VI, because it looks like most people are using VI basically like Notepad. You go into VI, you enter insert mode, you move around with the arrow keys, you backspace to delete, you copy and paste using the mouse. And if that's what you're doing, that will work, but you may as well be using Notepad, right? That's really the same functionality. So I want to talk a little bit next week about VI and just give you an idea of some of the things you can do if you get out of insert mode and stay in command mode. So we'll do that too. So if you're not sure how to upload your code, come by office hours and let's explore what tools you have available. On Windows, right, if you run Notepad++, you can also usually save that as a PDF, or you could say print to a file and that'll save it as a PDF. If you're writing in Word, if you can get it to stop doing all of the auto formatting for you, that has an export as PDF option. And so that's one way. If you're in Linux, you got a billion options, right? You can do an A to PS that automatically converts your ASCII file to a PDF. And you can pretty print it and all kinds of things. So, but yeah, depending what your tool set is, just hop into office hours early in the week, right? Not Friday morning, but early enough that we can figure out what tools you have, and if you need to download and install something else, we can figure that out and so on. Trick is to just write the entire program in one go from top to bottom. You don't even need an editor, right? You can just like type directly into GCC. No. All right, cool. We are out of time. So if you're in 215, I'll see you this afternoon. Otherwise, have a fantastic weekend, and I will see you Monday. All right, thanks.
Have a good weekend.
You too.
Have a great weekend.
Thanks.